Hello students, welcome to my YouTube channel, and in today's lecture we are supposed to discuss some very interesting numericals based on lens equation, right? Before that, we need to understand regarding the power of a lens. Let's first discuss that particular topic, the power of a lens. Now students, we all are aware that a convex lens converges a parallel beam of light incident over it, while a concave lens diverges a parallel beam of light incident over it. So power of a lens basically indicates the ability of a lens to converge or diverge a parallel beam of light incident on it. So it is the ability of converging or diverging a parallel beam of light incident on a lens. That is known as power, right? And mathematically or quantitatively, it is defined as reciprocal of the focal length. In meters, focal length should be in meters, right? So again I repeat, convex lens, you are aware it's of converging nature. Concave lens, we are aware it's of diverging nature. We have justified these two topics, isn't it? So basically, a lens either converges or it diverges. The ability of a lens to diverge or converge a parallel beam of light incident on it, that is known as its power. That's the qualitative study. Now quantitatively or mathematically, how to measure the power of a lens? So it is given by reciprocal of the focal length of the lens. And please do remember, focal length should be in meters. In case it is in centimeters, so don't forget to convert it in meters. So it will be 100 by f in centimeters. Clear? So SI unit of power is meter inverse. Reciprocal of meter, so it will be meter inverse. It is also known as diopter. Represented by capital letter D. It is represented by capital letter D. Now look student, here also we need to make use of sign convention. We have discussed the topic that convex lens, its focal length is positive, so its power is also positive. So for convex lens, converging lens, power is positive. For concave lens or diverging lens, the focal length is negative, therefore power is also negative, right? So in case lens is placed in a rarer medium, so in that case, convex lens, its focal length is positive. And accordingly its power would be also positive. While concave lens, which is a diverging lens, its focal length is negative and accordingly its power will be also negative. So students, what I mean to say is that only by considering this sign on the power of a lens, we can easily identify the nature of the lens, whether it is converging or diverging, right? So this was regarding the power of a lens. Now we will start with these numericals. Please concentrate on the first question. Let's start with the numericals and we'll be making use of the mathematical formulas which we have already derived, which we have already discussed. So let's start with the first one. Okay. A needle placed 40 cm from a lens. Draw a diagram. And on the screen place 80 cm on the other side of the lens. Students, please consider on the question, right? As I have told you in mirrors also while solving numericals, if you have got a sound theoretical knowledge, you can easily predict the answer without doing any mathematical calculations, right? So here also, all the ray diagrams, whatever we have studied in the case of mirrors, lenses, it should be in your mind. It should be crystal clear. Now look, the question is, a needle placed 40 cm from a lens forms an image on the screen placed 80 cm on the other side of the lens. So in this question, the image is formed on the screen. So it is real. So students, only in the case of convex lens, the nature of the image obtained is real. So it must be the case of a convex lens. So identification of the lens, that's already done. What is the type of lens? It is a convex lens or a converging lens. So this part is over, right? The first part we have done. It's a convex lens. So you can draw a rough diagram. You need not to draw the entire ray diagram, just a rough diagram, just for your reference. So it's a convex lens. A needle placed 40 cm from a lens. So this is a needle. This is the object. It is placed 40 cm. This is the object. Forms an image on the screen placed 80 cm on the other side of the lens. Here the image is formed at a distance of 80 cm on the other side. Now, since the image is real and inverted, it will be like this, right? This is the image. Just draw a rough ray diagram just for your reference. Identify the lens. This we have done. It's of converging nature on a convex lens. Determine FH2, that is the size of the image, if the size of the object is given to be 15 cm. So what to do is write all the given data. Make use of sign convention. Incident ray is along this direction, left to right. So it is measured against the direction of the incident ray. So it is minus 40 cm. V, it's given, this is the optical center, it's given the distance, again measured along the direction of the incident ray. So it is positive, so it is plus 80. Also, for real image, V is always positive in case of lenses, right? F is to be determined. And H1, it's erect, it's given to be plus 50. So we can easily predict that H2 must be negative, isn't it? So before doing any sort of calculation, these are the predictions which we can make accurately. Now let's solve it. What's the relationship between these three? It is 1 by F is equal to 1 by V minus 1 by U. Let's substitute the value and solve it. 1 by V, 80 minus 1 by U, it is minus 40. So it is 1 by 80 plus 1 by 40. So 80 is LCM, 1 plus 2, that is 3 by 80. So focal length would be 80 by 3 centimeter. So that will give you 26.67 centimeter. And it's coming to be positive. Focal length positive. It means that it must be of converging nature, or it is the case of a convex lens, as we have predicted much earlier before starting this numerical. Right? So focal length, this has been obtained. Now we need to find out the size of the image. So what's the formula? M is equal to H2 by H1, and in case of lens it is V by U. So let's substitute the value. H2 by H1. H1 is plus 15. What about V? It's plus 80. What about U? It's minus 40. So H2, it will be equal to minus 30 centimeter. So as we have already predicted, the image must be inverted. This negative sign suggests that the image is indeed inverted and enlarged. So the size of the image is greater than that of the size of the object. So students, theoretically and quantitatively, mathematically, there should be synchronization. I mean, every theoretical concept can be made use of while doing such numericals. Right? So this was a very, very basic, simple question based on lens equation and linear magnification. Okay, let's proceed with the second question. Second question is, students concentrate on that particular question. A convex lens is to be used to throw on a screen 10 meters from the lens a magnified image of an object. If the magnification is to be 19, find the object distance and the focal length. So, second question. It's given it's a convex lens and is to be used to throw on a screen 10 meters from the lens. The screen is at a distance of 10 meters. So, it's given it's a convex lens and this is the screen. And it is at a distance of 10 meters. So, obviously, image is obtained on the screen. So, this is where image is obtained. Right? So, image is real, it is inverted. So V is given. It is given to be plus 10 meter. For real image obtaining that is obtained on the screen, V is positive for lenses. These are the facts which we are all aware of. A magnified image of an object. If the magnification is to be 19, find F and U. Look, here magnification. Now students, a very, very important fact. Now from this question, it is pretty clear that the image is obtained on the screen. So it is real and inverted. The image is real and inverted. I have told you, for inverted image, linear magnification is negative. For erect image, linear magnification is positive. Here, the magnification is 19. But since the image is real and inverted, here it is to be assigned negative sign. This is very, very important. If you forget to assign this negative sign, the entire numerical will go wrong. You will waste your time. So this is very, very important. Since the nature of the image is real and inverted, why it is inverted? Because it is real. Why it is real? Because the image is obtained on the screen. So for inverted image, linear magnification is negative. For erect image, linear magnification is to be assigned positive sign. So this is it. This is given. So magnification is given, image distance is given. We are supposed to find out the focal length. Focal length of a convex lens, it should be positive, and U, it should be negative. These two are to be determined. So let's find out the relationship between these two, right? So we are aware M is given by V by U. We all are aware of it. In case of lenses, M is given by V by U. M is minus 19, V is 10 divided by U. So U would be equal to minus 10 by 19 and it would be in centimeter. So this is U. Right students? So U can be easily obtained. What about F? Now in order to obtain F, we will make use of this formula. 1 by F is equal to 1 by V minus 1 by U. Let's solve it. 1 by F is equal to 1 by V. V is 10 minus 1 by U is minus 10 by 19. Minus 10 by 19. Right? So what is will do is 1 by 10 plus 19 by 10. So that will give us 10, 1 plus 19. So it will be 20 by 10. So F is equal to half centimeter. Clear? Or it is equal to 0.5 centimeter. So students, this is how the question can be solved. And positive sign represents that the nature of the lens is convex, which is already given in the question. So this was the key point, to make use of sign convention in all the terms U, V, F as well as in M while solving numericals. Right? So this is the object distance. This is where the object must be placed somewhere over here. Right? And this is the focal length of this particular lens. Right? Okay. Let's proceed with the third question. Third question is, students, an object is placed at a distance of 1.5 meter from a screen and a convex lens is interposed between them. Okay, this is the object, suppose. We are discussing third question. And this is the screen, suppose. This is the screen. Screen means the image is to be obtained on the screen means image must be real. And this is the distance between them. The distance between them is given to be 1.5 meter. It's given to be 1.5 meter. This distance is given to be 1.5 meter. Right? And a convex lens is interposed. Interposed means it is placed between them. Okay. Over here, like a convex lens is placed in this particular manner. Right? The magnification is 4. Means the size of the image obtained is 4 times the size of the object. This is suppose the object and this is the image obtained. This is the image. Its size is 4 times. Now we are supposed to find out the focal length of the lens. This is given, students. So what to do is, if it is considered to be x, then It is 1.5 meter, this is x meter, so the remaining distance would be 1.5 minus x meter. Right? And also, now let's see what's given in the question. Linear magnification, just as was done in the previous question. It is the case of a convex lens. Screen is placed, means image is obtained on the screen. So nature of the image is real and inverted. Nature of the image is real and inverted. So it is magnified as, magnification is 4. So since it is inverted, so it should be assigned negative sign. This is again a very, very important point. Linear magnification is given to be -4. Minus sign is to be assigned as the image is inverted. Right? What about U? Make use of sign convention. This is the direction of incident ray. So U is measured along this direction from the optical center. So it is -x. What is V? Image is obtained real. Along the same side as that of the incident ray, it is measured from the optical center, so it will be positive. 1.5 minus x. It's in meters. So, you are aware of this relationship between these three. So, what you get is m is equal to v by u. That is -4 is equal to 1.5 minus x divided by -x. So, cross multiplying, we get 4x is equal to 1.5 minus x. So, that will give us 5x equals to 1.5 or x equals to 0.3 meter. Right? So, x is 0.3 meter. So, this distance is 0.3 meter and the remaining distance will be 1.2 meter. 1.5 minus 0.3. Clear, students? So, what we have done is u has been obtained. It is minus 0.3. V is obtained. It is plus 1.2 meter. Now F is to be formed. So we know the relationship in these three. Let's make use of lens equation. So it is 1 by V minus 1 by U is equal to 1 by F. So let's try to evaluate it. 1 by 1.2 minus 1 by minus 0.3 is equal to 1 by F. Therefore 1 by F, it will be equal to well, let's increase this step. 1 by 1.2 minus will become plus. Right? So, what to do is 1 by f, it will be equal to LCM can be taken as 1.2, 1 plus 4 times. So, it is 5 divided by 1.2. Or taking reciprocal, we get f is equal to 1.2 divided by 5. So, that will give us the answer. So, 0.24 meter. So this is the focal length of the convex lens under consideration. 0.24 meter or 24 centimeter. So again, students, this was a very, very interesting question. I hope you have understood it completely. We are not making use of any other formula except the lens equation and the expression for the linear magnification and sound theoretical knowledge. Right? When the image is real, when it is to be assigned positive sign, when m is to be assigned negative sign, right? These all are the points which needs to be kept in your mind while solving these type of questions. Okay, so third question is also over. Let's try the fourth one. Fourth question is, student, just read the question carefully. A lens is placed at a distance of 20 centimeter. A lens is placed at a distance of 20 centimeter, produces a virtual image 2 by 3 the size of the object. 2 by 3 the size of the object. Find VF and the nature of the lens. This is also a very interesting question, and without doing any calculation, it can be theoretically predicted regarding the nature of the lens. Again, let's consider on the question. A lens is placed at a distance of 20 centimeter. Produces a virtual image 2 by 3 the size of the object. Virtual image, virtual and erect. 2 by 3 the size of the object. Okay, means H2 is equal to 2 by 3 of H1. It's given. Virtual and erect. Since it's erect, so H2 would be positive. So H2 by H1 it would be equal to 2 by 3. H2 by H1 is linear magnification, so it is 2 by 3. Why it is positive? Because virtual and erect, right? So 2 by 3 means linear magnification is less than 1. So the size of the image is smaller, right? It is virtual and smaller. Now look student, in the case of a convex lens, whenever the image is virtual, then it is always magnified. Remember the situation. In the case of convex lens, when the object is placed between the optical center and the focus, then its virtual, erect and magnified image is obtained. But here, the image is given to be virtual, but its size is less than that of the size of the object. That is, in this case, the image is virtual and diminished. So, image is virtual and diminished. It is feasible, it is possible only in case of a concave lens. In concave lens, wherever an object is placed in front of a concave lens, the image obtained is always virtual, erect and diminished in size. So it is satisfying that condition. So what about the nature of the lens? Nature of the lens is diverging. Diverging lens. Diverging lens means we are talking about concave lens. Right? So this is over. I mean, nature of the lens, it can be easily predicted by your theoretical knowledge. Right? Let's find the image distance and the focal length. Okay. So U is given at a distance of 20 centimeter. Right? So U is given to be minus 20. U is always negative. So M, you are aware, it's given by V by U. So M is given to be 2 by 3. V is to be determined. U is minus 20. So what do you get? V is equal to minus 40 by 3 centimeter. That is minus 13.33 centimeter. Negative sign indicates that nature of the image is virtual. In the case of concave lens, always the image is virtual. That is, it is found on the same side as that of the object. Like this is the case, isn't it? There is a concave lens. This is the optical center. If an object is placed over here, this is suppose the focus, the image would always be formed somewhere over here. This is object, this is image. So here image is always formed on the same side as that of the object and it is always diminished. That is what we have verified over here. Now let's find out the focal length. Now focal length can be found by using this formula. 1 by f is equal to 1 by v minus 1 by u. So we get 1 by v. V is minus 40 by 3. Minus 40 by 3. Minus 1 by u. U is, where is u? It is minus 20. So what you get is 1 by f is equal to minus 3 by 40 plus 1 by 20. So LCM would be 40 minus 3 plus 2. So it is minus 1 by 40. So f would be equal to minus 40 centimeter. Again, from the negative side of the focal length, it can be easily predicted that the nature of the lens is diverging. It is only for concave lens in rarer medium that its focal length is negative. So students, I hope you have understood all these questions. They are very, very simple, isn't it? So please keep trying such numericals, and it is only through practice that you can achieve the confidence. And please do as many numericals as you can. Right? All the best then, and keep studying very, very well. Thank you.